Should we wait a few more minutes for people to join us?
Yeah, that sounds good.
Yeah. It looks like a few more people are coming.
Share it with people later. All right, thank you very much for being here. And should I get us started? How does it usually work?
Yeah, you can go right ahead.
All right, perfect. So thank you very much for having me. This event is sponsored by Miracosta Math Club and Data Scholars Club. And we're going to look at what is data science, what is new about data science, and what are some of the data science projects that we have seen, and how did those projects become motivation for project-based classrooms at community colleges? What are the nature of the projects? And lastly, I will showcase 3-4, depending on how much time we have left, showcase 3-4 of the project that people worked on. Couple of people might have seen some of these presentations. I know Melina and Arman Eftekhari, they helped me with proofreading the presentations. So some of it they might have seen it, but a big portion of it is about data science, so I don't think I've seen that part. So I'll change my acknowledgement to, I want to acknowledge all the students who took Miracosta statistics courses, because they had a big role in what we did in project-based statistics. I want to thank Math Club and Data Scholars Club and my two wonderful assistants, Delina and Diana, whose motivation run me crazy every day. So what is new about data science? Why data science? Because the systematic use of data to inform human understanding and decision-making has been around for thousands of years. In fact, modern science largely is on quantifying what can be said about the complicated and real-world events from experimental evidence. So how is data scientist and how is the data science different from other sciences? So recent technological advances create data at an unprecedented amount. So these companies that you see every day, they're producing massive amount of data. And most mechanical devices nowadays are capturing the categories of human behavior. And there's so much data that look at how we use our phone, inventories of goods we buy, things that we search on our IP addresses. So this is where the data science comes to play. So with this massive influx of data, it comes a new set of problems. So how can this catalog of data be organized and understood? How can we get this massive amount of data and organize it, visualize and understand what is the abstract idea behind it? Can questions be asked of such a data to keep pace with the rate of collections? What practical problems must be overcome to implement solution to such problems? And this is where the data science as a discipline come to play, by combining what we know about math and statistics, by combining what we know about the computer science and programming, and by bringing the domain-specific knowledge from wherever there's massive amount of data is coming from. As a data scientist, you try to make sense of the abstract stories that are hidden beyond massive amount of data set. So treating this data as an abstraction for which you as a data scientist attempt to solve and unravel the hidden mystery behind it is exactly what the data science is about. Some of the examples of the project that data scientists have worked on, for instance, some of the things you see on the news is predicting elections. So surveying the population to understand the electorate and their political leaning, deciding who to include in the survey, involves attempting to represent the voting population using the population demographics. So data scientists try to get that demographic information, and based on that, create models that predict what a state is going to vote for what political parties. Another example would be product recommendation. You go on Amazon, you search something, and you're going around like freely, going around. So the data on the product purchase is along with the description of purchasing customers, inform a model of purchasing behavior. And based on that purchasing behavior, not only a picture of current customer, but it can also be used to suggest product recommendations. So that's why when you go on Amazon, and nowadays even with Alexa at homes, or with Hi Google, or with Siri on the iPhones, a lot of times, a lot of information are being captured. For instance, a lot of people are noticing when they have a conversation at home about a totally topic that has nothing to do with what they do shopping online, all of a sudden on their browser, they get advertisement about those. Those are the massive amount of data that are being collected with Amazon's, with Google, with those major companies. And the data scientists take that data, create a model, and predict the future behavior of the customers. Another example of what data scientists is the photo sharing application. When you do the Instagram, Snapchat, Google Photos, it takes your photos and try to match it with the existing photo that exists. For instance, here they take the picture of the crease spine and look at the patterns that they all share, and based on that, they match it with the different faces. And this is done by encoding the relevant portion of a person's face, and then the digital image get translated into bits and pieces of data that they use to predict or match the faces of a person. And that exactly became the motivation. This real life context became the motivation for people in data science education and statistic education. People like Timothy Bayer looks at the effect of guided project-based learning activity on a student's attitude about the statistics and data science in introductory courses. People like Lisa and her colleague, they compare a learning experience where you go through a traditional statistic course versus a statistic course which is project-based and multidisciplinary. And they see a huge difference in a student motivation and a student performance between the two classes. They also found that the American Statistical Association had a group of researchers and educators get together in 2007 and late in 2006, and they look at what works in the data science. Data science is much newer than that. It's fairly almost 10 years old. So they look at the statistics and see what works. And they have noticed that project-based pedagogies align perfectly with what they publish as the guidelines for assessment and instruction and statistic education. So these project-based classrooms also match what in the national level different organizations are promoting. And some people in 2020 actually tested that. They took the GAZE recommendation from ASA, the American Statistical Association, and applied into a classroom. And they noticed that students who were in a flip classroom based on the GAZE outperformed the other people. So based on that, we created projects in data science and statistics courses. So some of the projects are ongoing projects. For instance, some of the classes we had a weekly project. We had some faculty can have project as a quizzes, as exams. Some they can have one final projects. Some they do data analysis as exam questions. Some they provide data for students, and they try to repeat this authentic research and data experience for students. Some of the example of what we have done as a weekly or as a temporary projects or quizzes. For instance, those of you who have taken my Math 103 class, when we do a weekly project, one of the project is after you become familiar with the statistical studies and the effective way of conducting experiments and collecting data for observational studies, the project prompts you to pick a study and criticize it based on what you have learned in that module. So this gives you a chance to apply what you have learned into a real life context. Those of you who have taken my statistic or is going to take my statistic, there is another activity we will do, and we're going to check whether can you ever become a millionaire by going to a casino. For instance, if you play American roulette over and over, if you play on one number versus 4 numbers, is your chance of winning the same, or is your chance of winning increases? So that's another activity that in introductory statistic course, you evaluate and you check using probability to see if that's true or not. Another is a project, the short-term project that students worked on is looking at the consumer rating for different fast food companies. And these are publicly available in the public domain. And we collect them every semester. They're being renewed every year and every quarter. So we collect a massive amount of those data and have the students compare 3 fast food companies that matches their surf ID and look at their consumer rating. Is there a significant difference between them? Is there one that stands out? So that's another project that is a short-term project that students work on. Another example of short-term project that we have worked on is becoming a financial advisor. For instance, if you're advising someone near the retirement who want to make money using a stock, what would you recommend them to do? So you get almost 10 different stock market, and we focus on the penny stock to make it more tangible and more real. Penny stock are a stock that the value is around $1 or less than $1. And as a financial advisor, you use the tools you learn in statistics to advise a person who is close to the retirement versus a person who want to make a quick money. So you very much advise them what to do with their money. Some of the other project ideas we have, I share this presentation with you in the chat room. So let's see if it works. So you can follow along. This is some of the project ideas that we have been compiling. We have been gathering together. Body fat data. This was the data collected from the BYU Human Performance Lab. Some of the project that we have had access to the data was CO compensation 2014. That is actually being updated for the most recent year. The cost of living and the cost of living adjustment. Donor profiles, the frame, Salmon, and these are all real life data. This is part of that massive amount of data that as a data scientist, depending on what discipline or what domain specific you work with, you be analyzing. No, this is interesting. I don't know why would someone look at the fingers and the height of cream, but you have that data also. Here is so if you click on those links, this is what you will see. This is some of the possible data that students can use and work on. Fuel economy, late arrivals at the airport, listening to music while taking a test or studying, pulse rates, real estate samples of 1,200 houses. So these are all the sample of data, the data set that as a data scientist, you work on at some point in your life. Now, one of the projects that is not a short-term project, usually takes a whole semester or a whole quarter to perform, is the final project. And the final project is very much what exactly a data scientist do. Typically what we do is you select a group of people, 1, 2 or 3 people. Typically we do this in the face-to-face statistics course. For online is, I piloted one semester, but coordinating this group work were tedious work. And instead of that, we decided to do unit projects for the online statistics course. Or for most face-to-face classes that me and a couple of my colleagues teach, we encourage the students go through this very much scientific cycle, this scientific method that as a data scientist you would use and they use. So a lot of times you come up with a research question, looking at a domain specific, you're interested in discovering something that gets your attention. Like for instance, if you're working for Illumina, they might be interested in looking at certain patterns in the DNA sequencing of people in the southern hemisphere or people in northern hemisphere. Or they might be interested in looking at the DNA double strand breaks of the leukemia patients people who are responding to a certain treatment, people who are not responding to a certain treatment. So as a data scientist, a lot of times the research question can either be yours, or it can be a group of scientists, a group of people that you work with. Or you can work with Amazon and they give you a massive amount of consumer data and they want you to create a model to predict what will happen. What's the probability of this person buying, for instance, another shoes, or what's the probability of this person buying another products? So you have this research question that you work with. The next step in the scientific method, you collect data. So you want to collect the data that answer your research question quantitatively, but also represent the population, or it is part of the experimental study and you want to have the random assignment. You collect the data, then you analyze the data. So in a statistics course, we go over the first thing you do with data. What the first thing data scientists do with the data, they visualize it through Python, through R, through web applets, through Excel, whatever tools they have. They want to visualize the data. They want to see what does this data look like, because otherwise you have a set of numbers that there are beautiful numbers, but there's no meaning. There's no sense making behind them until you graph them. You analyze the data, and based on some historical data, you test the claim, you estimate a characteristic, or you create a model. You do a linear regression on making prediction for the population of human population across the world. So that's after doing the data analysis, you very much try to fit a model and predict the future. That's one of the things that data scientists do. Or you make sense of the phenomena you're looking at. Was the DNA double strand breaks random, or was that around certain genes that relate to the leukemia cells? So that depends on your research question. In your data analysis, you try to answer that research questions. And as a data scientist, a lot of times you prepare a report, you present it to the people you work with, you communicate with them, and a lot of times they're like, this is wonderful, but we need to have more questions. So they send you back and you go in this cycle of scientific method over and over, over and over and over. Now, what I want to share with you is 3-4 of those student projects that they went through this cycle throughout the Math 103 statistics course. And we try to replicate what a data scientist would do. The first one, a group of students, they were interested in looking at if there is any association or correlation between ethnicity and crime in Los Angeles. So what Brittany, Jasmine, and Mystica did, they decided to investigate whether there is any correlation or relationship between ethnicity and the crime in the city of Los Angeles. Now, I keep saying crime because I presented this data last year at the conference, and I used to call it the arrest data in Los Angeles. I got a lot of foreign feedback from a colleague who lived in Los Angeles and was like, why do you always talk about the LAPD? I'm not, because that's the only data we had access at that moment. So we are looking at if there's any correlation between ethnicity and crime in the city of Los Angeles. So what they found out was that LAPD actually have been providing their arrest data from 2010 even up to now, but at the time was 2019, which had more than 4 million arrest records throughout the city and the the Los Angeles metropolitan. So what we did in order to conduct this study, we randomly selected 100,000 arrest records. So in Python, there is a simple code you write, and out of the 4 billion, you would select a random sample. The reason we did that because we couldn't work with this huge population. At the time, we couldn't. We tried it, but the computer crashed. We tried it a couple of times, and someone had to shut down the desktop, so we couldn't process. So they took 100,000 random sample from this population and tried to answer their questions. And because the raw data from LAPD contains almost 1,000 different crime category, what these 3 students, Brittany, Jasmine, and Mystica did was they created these 6 categories of crime based on the LAPD records. And this was very much a qualitative work. So they got together, I sat with them, we went back and forth, they came up with these 6 different categories of crime in LAPD. And ethnicity, based on the LAPD data, was categorized in these 5 categories. So A, B, H, O, and W. And of course, it's more than that, but this is what the LAPD was providing. And this is what the raw data look like. So the 100,000 random sample we got from this population, this is what the data, this was the data they had to work with. So based on their analysis, this is what they found. So what you see on the left is the categories of the crime 1 through 6, and we see on the top is the ethnicity that the person involved in that crime identified as. No, I don't want to say, yeah, the person who was the arrestee. This is the ethnicity of the arrestee based on the LAPD data, and this is the 100,000 random sample they selected. So the idea was whether there was any association between these 2 categories, because you look at ethnicity, that's a categorical variable. You look at the categories of crime, that's a categorical variable. They wanted to see if you're in a certain ethnicity, in a certain ethnicity category, did you have a higher probability of being arrested in a category 3 or 4? So to do that, they use the chi-square test. Now, if you click on that link, it takes you through a Google Colab sheet, which this Jupyter Notebook, this Google Colab sheets are becoming very popular in data science. The powerful thing with this notebook, these are simple notebook. This is actually a Jupyter Notebook you can run on Google Colab. You have the link, you can download it to your own drive and then very much play with it. You can see the code that the scientists use. So this is beyond college level. You usually study this in calc-based statistics in senior year in data science pathways or in other engineering, sometimes even in master program. But the beauty of this notebook is that not only you see the content, not only you see what the scientist was as a scientist you were thinking, but they also include the code so a lot of people can replicate the study they did. So for instance, so these are some of the libraries in Python. So if you run those and you run this, this is what we call the chi-square distribution for different degree of freedom. Now, we have spent quality time in the statistics going over this, but I wanted to share with you this. Nowadays, with this advanced technology, the replication is not going to be a problem. And the reason this is huge, this is going off the topic, but in 2018, 2016, 2018, a lot of criticism start happening against qualitative research and quantitative research in humanities, social sciences, psych literatures. And the reason is there's an NPR podcast. If you had a chance, Google it. It talks about the replication of social sciences in the program called Hidden Brain. And it's quite interesting because they took a study that was well established and well known across the world in social science. They replicated it. And they noticed they were not getting the same data that the author, the scientists were getting. So the replicability of the data and the work is quite important in data science. So you see a lot of notebook being used in classes and nowadays in data science as a field because they want to keep track of the coding they did so people can replicate the study that they were working on. So going back to this chi-square test of independence, the null hypothesis, the assumption was that these 2 are independent. The assumption was that the arrestee ethnicity has nothing to do with the crime category that they were arrested for. And this is the statistical data they got. And this is the residual. So in a chi-square test, you create what we call the expected value table. So if these 2 are independent, if these 2 has nothing to do with each other, what would this table look like? Then you take the observed value and subtract it from this expected value. So this residual tells us, it told the students which category was close to what was being expected if they were independent, and what categories were way different from what we were expecting in that category. So I have a question for you that I want you to send me a private message in the chat room. Based on this, so if we had more time, I would have people go and introduce themselves. But how would you answer this question? Was there an association between arrest and ethnicity in Los Angeles? Go in the chat and send me a private message. I won't share it with anyone. It's between us. What do you think, based on this chi-square test and this residual table, do you think there was any association between ethnicity and crime categories in Los Angeles metropolitan? And if you say yes, tell me why. If you say no, why not? Come on. We have 7 people in the chat room. Well, beside me is 6 people. So the chi-square test we ran, it checked for the association and the null hypothesis that they're independent. What is that p-value? And that huge chi-square test statistic tells us. Our friend, I'm putting all of you on a spot. Take a statistic so you can answer the question. So what is interesting though, because of the probability of getting such a sample, if they were independent, the probability of getting of such a sample is very unlikely to happen. So the p-value tells us what's the probability of getting a sample with such a severe residual that we see in this sample. And this is very unlikely because the probability of it is way less than the threshold of 5%. So it's 0.0001. So if we assume they are independent, the probability of our sample is very unlikely to happen. So what this student concluded was that there should be an association between the ethnicity and the crime rate. And in their conclusion, they talked about the residual in different categories. But when they were presenting this at the end of the semester, a couple of the students brought a very good critique to this study. And they were like, instead of independence, you should have checked this for homogeneity of the population. The people were like, what do you mean? They were like, what if you look at these crime categories? What if you look at these ethnicities and compare this to the demographic of LA County and Los Angeles metropolitan? Because if they were like, if there is homogeneity between the LA demographics and what you see in this different ethnicity, then this arrest data represents the population demographic of Los Angeles. And that was a good criticism. That was a very good solution. So I don't know what the students did with the study, but that was the next step they would have done. Exactly, yes. According, someone sent me a private message. According to the very low p-value, there's an association between ethnicity and crime. Excellent. Yeah. So the election fraud in Armenia was another quite interesting study that students work on. So Christine and Tatiana, they wanted to see if they could prove there was election fraud in Armenia. So this class happens to be exactly around 2-3 years after the revolution, after the civic revolution in Armenia. So they wanted to see if, in order to answer that question, if there was an election fraud, they look at the correlation between the voter population per polling station and the proportion of people voting for the majority party. So the idea was that there was this majority party that they were manipulating all the voting stations and all the electorals. And if they could prove that this relationship changed from pre-revolution to post-revolution, they could claim that's enough evidence to show that there was election fraud prior to the revolution. And they also checked whether the participation proportion in elections significantly changed from pre-revolution to post-revolution. So to do this, they were able to get access to the data from Central Electoral Commissions of the Republic of Armenia's website. So one of the students actually was from Armenia, and she was able to access the data, translate a lot of Russian the headings in the file, and they created a linear regression for 2017 versus 2018. And they also compared the two population proportion. So one of the things as a data scientist to do, I gave you this link. This takes you to a Google Colab that some of my colleagues have started using, introducing linear regression. So you see nowadays with Jupyter Notebook, this is actually from a book, Python Data Science Handbook. What you can do is not only introduce the topic, you also introduce the code. So these are the library we need. So in Python is library based. So you download a lot of command that you're going to use, and then you run the command. And in this case, we get a scatter plot. And then the nice thing with these notebooks, with this Google Colab notebook or Jupyter notebooks, it takes you through the content, but also you have access to the code that they use to introduce that topic. So if you're more interested, please take a go, download the Jupyter notebook into your own Google Drive and just click and go through the whole thing. It's quite fascinating. So this is what the raw data looked like. So we spent almost 2 weeks to translate a lot of headings. Then we went back and forth to make sense, to make sure that it made sense. And this is the scatter plot for pre-revolution percent of voters per voting stations and the percent that they voted for the majority party. And this is the linear regression. This is the best fitted model pre-revolution. So as you see, there's a strong correlation, not as strong, but fairly moderate 0.656 R square correlation coefficient. But nevertheless, there is a correlation between the two. We can fit a linear model into this. They also look at the post-revolution data, and unlike to what they have seen, the post-revolution data, the proportion of voters and the proportion of people who vote for the majority party was actually went in a negative direction. And this is what they got for the correlation coefficient. So now there was not a strong linear model that they could feed into this data set. So I had another question for you. Based on what you see, what do you think? Was there any correlation between voters' proportion per polling station and the proportion of people voting for the majority party? If there was one, do you think there was election fraud in Armenian happens in 2017, pre-revolution time? Send me a private message in the chat. Is post-revolution, and this is pre-revolution. Do you think they were able to prove that yes, this could be as evidence to kind of show that there could have been an election fraud in Armenia? Interestingly, the part that they didn't include in this study, the proportion of people who voted post-revolution actually went down versus pre-revolution. I don't know what's the psychology or sociology behind that, but it was quite interesting. One of the things they use in their criticism, I see a couple of people are saying the p-value being very low. True, but also this p-value refers to the slope of the best fitted linear model to the data. But some of the things that Tatiana and the other students use, they're going to kill me, I forgot her name. I have it in my notes. They look at the correlation coefficients. They were like, there was a strong correlation between proportion of people who voted and proportion who voted for major party pre-revolution. That means majority of the people who voted were voting for for the major party. That was not the case post-revolution. There was a very weak correlation between the two, and it had a negative slope. So they were like, I remember Christina and Tatiana. Christina took that and published what she had found in a magazine in Armenia, and she got a lot of positive feedback from people. They could be biased in their statement, but she had done a beautiful job to show that yes, that this revolution, one of the main reasons for this civic revolution was the election fraud in their voting system. The one other thing I want to share with you is Zoe, one of the students, wanted to look at, was there a significant difference between the non-organic and organic produce prices? So in order to do that, she used a t-test to answer this question. Is there a significant difference between non-organic produce prices and organic prices from big chain grocery stores in San Diego County? And again, if you click on that link, that kind of takes you through a Google Cloud that faculty and students can use to study the t-test to compare two population means. So first you download all the Python libraries needed, and then you go through the theory, the content, and come back and look at a couple other examples and do visualization. I very much do what the data scientists do. And with this notebook, Jupyter Notebook, you're able to do that in a classroom. So what Zoe did quite interesting was she chose 10 towns, 10 random towns in San Diego County. And out of the 10 towns, she randomly chose a total of 18 big chain grocery stores. So she got a hold of this from the county website, this information. She went to most stores' website to gather the non-organic and organic prices for 6 popular produce that a lot of majority of people purchased: apples, banana, lemons, broccoli, lettuce, and celery. Now, this is data for 2019. This 6 produce could have changed. She also chose items that are available year-round, so she could get a good average prices for them. And this is what her raw data. She did a lot of work on collecting this data from the different websites. And you see the major towns in the major cities in San Diego County. And this is what she found when she compared the prices. The low p-value showed there was a significant difference, a statistically significant difference between the two prices. And you see the non-organic being cheaper than the organic price. You already know the answer to this one. I want to share with you one other thing. So this study, I owe it to Scott Falstrom, Professor Falstrom, also Professor Roxy Pick from Cal Poly, and Kathy Kubo, a dear friend of mine from College of Canyon. We were, 4 of us, we were collaborating with Chancellor's Office of California Community Colleges, their Statistics Institute, and we were conducting workshop for faculty across the state. And Scott, in one of the night that he was talking to his family, they know that they were watching a documentary about Flint of Michigan. And so I will share with you briefly what happened in Flint, Michigan, and we use that data and turn that into a project for students in statistics. So why we chose water? Because water is very much the essence in life. In every cycle of life, you see water being the primary substance that we need. What happens in Flint water crisis was that the water that they were pumping, the water main pipe was lead pipe. And the Detroit water that they originally were using, it was a good water, and it didn't have that much residual. But when later they switched to the Flint water, what happened was the lead pipe started gathering, so this is Flint River water, because there was a lot of substances, the pipes start accumulating the lead in the pipes. So they start causing lead contamination across the city of Flint, Michigan. And if you remember, if you look on the news, this was huge because they end up, a lot of people, so this is the link you have, you can check it out. A lot of people end up drinking that lead contaminated water, and a lot of families with kids and children were affected with this. It got so bad. So this is what you see prior to switching the water to the Flint. And as you see from left to right, the right is what people were getting out of their homes when they were drinking their tap water. It got so bad, so the crisis became so bad that they ended up sending the National Guard to help distribute bottle of water to the local resident, because a lot of small kids and families were getting sick, and a lot of, unfortunately, people lost their life because of this lead contamination. So when we set this up, we look at the mean lead level from the last quarter of 2015 and the second quarter of 2016. So this is when, during this year, was when they switched the water from Detroit into Flint River. And we wanted to look at if there was a big difference in the mean lead level between these two quarters, because they monitor this regularly. And what we created, so this is the raw data that we were gathering, any lead result above, I remember, I think 3.4 was contaminated. So all these red that you see are contaminated level of lead in the water. And when we compared it to the last quarter of 2015 versus the second quarter of 2016, we noticed that there was a significant difference between the two. And of course, the second quarter of 2016, after switching over to the Flint, there was a higher level of lead in the tap water in the Flint. And so we took this global issue, the water issue, the water contamination, and turned it into a project that a student could use in our statistics course. And of course, when you take a statistic, if you have taken a statistic, you notice there's a significant difference between the two. So this is a picture of a group of them, a group of students who presented their final project. And I want to thank every single one of them for being there. So I will close with this. So projects are a great way to do modern assessment. A lot of our classes are very traditional exam-based classes where it's far from the reality of what you do in the field. As a data scientist, you don't sit and take an exam. You take a huge amount of data and you apply the coding and the knowledge you have to unravel the mystery of this massive data set that we work with. We can choose topics for projects that emotionally are engaging to the students. We can choose subjects that connect to a student's intuitions and multiple levels, especially subject topics, context that they can relate to. And of course, keep in mind that the writing English language can also sometimes be a barrier, but with these projects, we can support them to overcome that barrier as well. Any question for me? Thank you for your time and thank you for having me.
I just want to say you did a fabulous job presenting this and putting together the whole presentation.
You're very kind. Thank you.
Yeah, I enjoyed it as well. Thank you.
Thanks for having me. I know it's a Thursday afternoon right before national holiday. Any questions for me?
Thank you for your presentation. I hope everyone here has a great weekend. It's going to be a 3-day weekend.
Yes, this week, tomorrow is the Veterans Day. So let us honor the people, the women and men who, and anyone who serve our country and serve the world. Let's salute them, let's cherish them, let's honor them tomorrow.